everyone, I wanted to do a really quick video about the weak law of large numbers. This is the version of the weak law of large numbers I'm going to be working with right now. In this case, I'm assuming that the variance is finite, which is a pretty big assumption. If we didn't have this, we would have to use a very different proof, which I'll probably do a video with in the future. So I first want to recall what it means to converge in probability. We say x of n converges in probability to x if the limit as n goes to infinity, probability of the absolute value of xn minus x greater than or equal to epsilon is equal to 0. So that's what it means to converge in probability. Just like the weak law of large numbers, there are a few different versions of this, but this is the version I'm going to be working with. The other thing I wanted to recall was the Chebyshev inequality, which says that the limit as n goes to infinity, probability x bar, or the absolute value of x bar minus mu, is greater than or equal to epsilon, is equal to the limit as n goes to infinity, the variance of x bar over epsilon squared. So you can see that the Chebyshev inequality looks very helpful for this situation, and so does having finite variance. So we notice the expected value of x in this situation, or x bar, is just going to be the expected value of x, which is equal to mu. The variance of x bar is just going to be variance, or sigma squared over n. Hence, using the Chebyshev inequality, we have, switch colors again, the limit as n goes to infinity, probability x bar minus mu greater than equal to epsilon is equal to sigma squared over n times epsilon squared. Should be a little more careful. Right, the limit as n goes to infinity. So this ends up being, the right-hand side ends up being equal to the limit as n goes to infinity, sigma squared n times epsilon squared. I did forget to mention, in these proofs, epsilon is just all epsilon greater than 0, where epsilon is a real number. That was important, sorry. That is for a fixed value. So as n goes to infinity, this becomes 0, and we are done with our proof. Xn converges in probability to mu.